We're from All Hands Active in Ann Arbor.
You're only supposed to tell them our name once we actually have things working and it feels professional.
3D modeling
If
and
you're
3D
rating the
printing.
session, you want to write down that Roger was running it.
Penguicon 2013.
Michael's also here from All Hands Active. So the plan was to go through SketchUp a little bit to like create a 3D model, and then if you're interested, which I heard some interest, we can talk about the different tool chains to get your model out to a printer, not necessarily a specific type of printer, while we're working on this. So if you have a laptop and lap space, you can install SketchUp. It used to be Google SketchUp. It's now, it was bought by a company called Trimble, but it's still generally free and available.
Does it work the exact same way?
Yeah, they basically like cut and pasted the Google name and it's Trimble everywhere. It still goes to Google's like 3D warehouse, but that also says Trimble on it now.
Okay.
So it works the exact same way as we're going to show here. We probably have outdated versions that still say Google on these, but really much hasn't changed. So that's available. It runs on Mac and Windows natively. It runs in Wine under Linux if you're interested. You don't have to use SketchUp to design for a 3D printer. You can use really any 3D modeling piece of software. Some are better than others. So when you 3D print, you want to print a solid model, and many of the 3D modeling software that's much of the 3D modeling software that's available is not for solid modeling. It's for doing actual 3D modeling that you'd use in animation or something. It seems great, like you think you could take a model from, say, a game or something and just print it out, but it doesn't always work because they cheat. They don't connect edges and faces. They don't fill things in you're not going to see. So there's all these holes. So when you actually go and get it to be a 3D model that you want to take to your printer, most times the 3D printer software will say, I don't know what to do with this. This is just like a bunch of flat shapes with no depth. And to a person, they look like it's a 3D object, but the printer's like, I don't know what you want me to fill in here. There's a giant hole. It's not watertight. So everything we do in SketchUp is not a solid modeling program either. It was originally designed to do buildings and architectural drawings. It has to be completely solid. Can't be holes in it anywhere. If you can somehow go through the outside into the inside, it's not going to print. Same thing applies for other pieces of software like Blender. Blender is a great piece of software, kind of complex to use so you learn the keystrokes, but it's not a solid modeling program. There's a few that are out there that are designed for actually 3D modeling for printing. OpenSCAD's one of them. There was a Tinkercad, which I believe is now closed unless you have an account with them already. That was designed for 3D printing. So everything they produce is a completely solid model. If you combine two squares, you can't hollow it out in a way that the printer doesn't know what to do with it. Any luck?
Possibly.
Okay.
I'll know whether or not I'm clueless or not in about...
You have to change the SketchUp directory and then just Wine SketchUp.
Ooh.
It's like .wine. So we've got that to do the 3D modeling. After the 3D modeling is actually finished, we want to get our code out to run on a printer. Whether you're running them on a hobbyist machine or a commercial machine, .stl is the file type that you want. Even the commercial machines use it. It's like a stereolithography format, but most of the machines have software that can translate that into G-code that the machine can actually run. If you're using the hobbyist machines, you'll use something like, if you're using a MakerBot, it's Replicator G will convert it to G-code, or Makerware is their new one. They both still work with all of their printers. Makerware is closed source, Replicator G is open source. There's also some programs, Slicer, SLIC3R, and I think it's KIS Slicer is another one. And so all that does is it takes your STL file and it converts it into G-code. And the G-code for 3D printing, all it's doing is telling it, move the nozzle here, turn it on, and print the model one layer at a time. So it's actually building it up from the first layer to the top. That puts some limitations on what you can do when you're printing. So things like overhangs without support. If your first layer is here and you want to print something here floating in the air, that's not going to work. It's going to fall right down. You have to have something under it.
Should I pass around maybe some 3D
prints that show
Yeah.
mess up.
Yeah, so it'll try and attach it to lower layers, but it doesn't always work as you would hope. So you have overhang issues. Some printers do multiple colors, but in general, most of them are one color right now.
The one I'm passing around is a good example of showing like how there's a set radius that you can go up to, but then if you look into here at the very top, which is like a 90-degree angle, there's stringies hanging down. So
Yeah, so he's got a lot of examples we can pass around, and he's got some good ones that show you the differences between a commercial machine and a hobbyist machine, or something that you can get like
this one
MakerBot.
was done on a replicator too.
And you'll see that they're very similar in quality, if not better.
What's this, the ABS?
This and everything's an ABS that I'm passing around.
Yeah. So most of the printers now have multiple material types they can print with. ABS is fairly common. A lot of people print with PLA, which is a cornstarch-based material, so it doesn't smell nearly as badly as ABS when you print with it, but it's also much more brittle. So there's that. There's HDPE, which is like what you find in milk jugs. You can print with that, a lot lower temperature. It's a little hard to find in the media that you might need. And then there's PVA, which is a water-soluble material. So if you want to print something, you've got two nozzles on your printer, and you want to print parts that interlock, you can print PVA in between them, and then soak it in like a hot water bath after for a few hours, and it dissolves. And so then you have parts that move inside each other that were printed in one shot. So it looks like we've got SketchUp working. Do you?
Fairly silly, so yeah. So a lot of people use SketchUp, A, because it's free, B, it has a very simple interface, but as Tyler noted earlier, it has the way it generates 3D models isn't necessarily the best way to go about creating models for 3D printing. You're basically putting together two-dimensional shapes. So here I've got, just a rectangle, has absolutely no depth whatsoever. So the 3D printer would not know how to print this. If you had an open-faced cube, the same thing would happen. So let's go ahead. We've got a rectangle there. We're just going to extrude that. There's a push-pull tool in SketchUp. So now we have a three-dimensional box, which looks awesome. And this would print fine. But if we go over here, and if I delete this top face, you can tell, like SketchUp gives it what looks like depth, but none of those faces have any actual depth to them. They're just flat planes. And if you were to actually try printing this, the printer would have no clue how to deal with any of those walls. So you're like, well, how do you create, if you wanted to create a box that had an open top, how would you do that?
This was not made on a MakerBot. So this one was not a MakerBot, but is an example of what else can be printed.
So if we delete that, if you recreate a rectangle, if we pull that up and kind of orbit to the top, you can create a smaller box inside that. So right there, just literally drawing another two-dimensional rectangle on top of it, and you can push that in, you push that down. You can extrude things with a very specific height. So say, I think I'm dealing with inches in here right now. Actually, I wonder if this will work. I'm gonna find out. So if I click that and then just type 10, does that work?
It does.
Excellent, yes. So if you wanted to, I'm gonna start over here. Nice. We can create, you can't see on the screen, but I'm typing 100, 100, and that'll create a 100 inch by 100 inch rectangle. Oh man, 100 inches by 100 inches is teeny. But we can extrude that up by another 100 inches.
They're examples of something.
Nope, not yet.
Creating drawings like a gear where you've got a lot of complex surfaces.
There's a bunch of different ways. I think
Gear library.
nice.
That's probably your easiest bet. There's another program called SketchUp, or called OpenSCAD, and they have gear libraries for it that you can basically punch in number of teeth, style of gear, if you want it twisted, if you need multi-phases, and then you say generate.
Something that doesn't fit in their library.
That's true. So you can
You can draw it by hand and then extrude it. So you don't have to use squares.
Yeah, you don't have to use squares. So if I go if I look at like a top-down view, I love this. It doesn't update the screen until I click. So you can freehand draw stuff, and you can't. It's not showing the status bar down below, but you can punch in angles, you can punch in lengths, distances. The only thing that SketchUp usually prefers is that you create a polygon with a minimum of 3 faces. If you don't do that, it won't highlight that section blue, and there's no way to really extrude it easily. But you can push, pull, you can extrude these shapes, you can copy, you can paste, you can rotate like 15 degrees if you wanted, 20 degrees if you wanted. So you can create fairly non-standard, fairly detailed shapes, but trying to do something with a lot of accuracy is very difficult in SketchUp. I'm not a professional with it, and talking with other people who do 3D modeling or CAD design on a regular basis, one of the things that they really don't like about SketchUp is they don't make it very easy for you to manipulate objects in a very specific fashion. You can get close, but it's hard to do detail work, whereas OpenSCAD is one thing that I know Tyler uses. Rhino is another one.
A lot of the things that are being passed around were actually done in a program called Rhino.
So little things that don't do well with 3D printing are overhangs, at least with most consumer level printers. So if I were to, create a smaller box right here and pull that out like this, that overhanging box right there, it wouldn't work. So the printer's working by essentially melting plastic on previous layers. And if it's not a very steep angle, if it's, I think, like less than 45 degrees, it can kind of build a little bit on itself. But at a 90-degree angle, the first like 10 layers on this part right here are just going to fall straight down. There's nothing for them to be supported by. You can build in support, and a lot of slicing software, which I think Tyler will talk a little bit about shortly, allows you to build in support, where it kind of builds like temporary scaffolding below your areas. But then you've got to clean that off. You've got to either cut that off with a knife, sand it down. There's a lot more detail work to make it look nice. That is one of the significant limitations. That doesn't matter what 3D modeling software you're using.
I have a question. Now, you mentioned that you have like different materials you can print in. Can a single printer print in different materials?
Right now, they basically have multiple nozzles on. If you want to do that, you can switch part of the way through, but there's a few problems with that. So it's very manual if you want to do multiple materials on like the same layer and you don't have 2 nozzles. You basically have to slice each piece separate and then insert pauses and merge the code back together, so you have to manipulate the G code when you're done. And so then basically what you're doing is you're printing the part of the layer in one material, the printer's pausing, moving off to the side, you're unloading, you're loading the other material, feeding it down through. Once it's ready, you tell the printer to resume, it prints the other part. And you have to do that for multiple layers. So say, just in general, it probably takes 2 to 3 minutes every time you have to change filament. So if you have an object that's 200 layers, it's going to take forever. It's not worth doing on a single filament printer. So some of the printers now have two nozzles on. The commercial machines you can get multiple nozzles on, and then switch material pretty easily. The other thing is you'll have to wait with a single nozzle. You have to wait for the temperature to change for that material. So like ABS flows at like 190, but flows really smoothly at 220 Celsius. But PLA is much cooler than that. So if you're switching between something like that, even PVA, the water soluble, is really cool. I want to say that's like 110 or 120 you print it at Celsius. So you have to wait to cool down, change the material, print the part, then wait for it to heat up again to put the other material in and print the next piece. So you really want to do it on a multi-nozzle machine, but it can be done on single.
So then on a multi-nozzle machine, couldn't you print like the supports and something water soluble and then just...
Yep. And a lot of the slicing software supports that. You tell it you have 2 nozzles and the second one will be used for support. Most of the times when you do that, you're letting the slicing software build the support for you. So if you go and build the support into your model, you have to be able to break it apart. So you're actually feeding the slicing software 2 models and telling it that the second model should be printed at this offset with the second material and the second nozzle at the same time, and then it'll know to go back and forth and change which one it's printing with. So you can do that. It's usually easier to let the slicing software deal with it.
It occurs to me that you could make some of the supports out of other materials and just put them here as a part of the table.
Well, So the problem with that is the nozzles are going to go down, and so if any part of your nozzle could hit the support material as it's printing, you could pause when you get to the height right before the and put the support in. Yeah. You don't want to do that with ABS. So you're printing on a heated bed with ABS. Anytime you change the temperature of the area you're printing, so if you have an enclosed machine and you open a door, you'll probably lose a few degrees in your build area just putting that small support in, and you'll get warping, and edges will be really funky. But with PLA, no problem, you can definitely do that.
Do you want me to do anything else with?
No, that's fine. I was going to pull up, plug in this guy, pull up, open SCAD, and slice
Might
it.
already be up here.
I tried.
You tried? Never mind. Alright, cool.
So if I can just have the projector cable.
Yeah, totes. Oh god, projector cable. And Tron mouse. You want Tron mouse?
Sure.
The built-in battery, right?
It's built-in battery and
Tron mouse looks awesome, not so functional.
It makes noise when you plug it in though.
So like if you were building a house that had an overhang, if you flipped it upside down and had it build it from the roof to the base, it would work.
If it's a flat, yeah, if you have like a flat roof with a flat overhang and you just rotate it, it's like, if you have like a letter T like this, you can't print it like this. But if you just rotate it like this, it'll work out fine. There's no overhangs.
Can't you print it with infill?
You can print it with infill, but even if you have, so if you have, you know, a house with nice eaves hanging down, you can have infill inside the roof, and that will help that from falling down. But where those eaves come up over the edge, those still aren't supported with anything below. So even if you like, if you only have eaves on two opposing sides, you can flip the house like this, and then the eaves are supported all the way up. But if you flip it upside down, then it's trying to teeter on, it's like an upside down pyramid. So there
You can
are a lot
solve
of
some of the problems with angles.
yeah, you can solve problems with angles. You can certainly print certain parts. So you could, if you had, if you wanted to have overhangs, you could print like the roof pieces separate, just flat on the print platform, and then you could use glue, or a lot of people will mix a little bit of acetone with a little bit of the ABS plastic, and that does a couple things. One, that helps fill in cracks, or it helps kind of adhere the plastic to itself. Acetone will melt away the ABS, so if there's just a little bit, it'll kind of remelt some of the ABS and help create a really good seal. So there's a lot of different ways you can get around the issue of overhangs. Yeah.
Okay.
I recommend throwing it.
Some of them are two color. Is that a nozzle thing? Or?
So a lot of, I mean, with any single nozzle printer, you can print with multiple colors. But like Tyler said, you have to, depending on what you're doing, you have to take out the current filament. You have to back that out. You put it back in, and it doesn't always adhere properly. Where you've kind of like let the top layer cool off, and then you start adding the next layer on. Oftentimes you'll have separation issues there. But multiple head printers, you can put red in one, you can put green in the other one.
So it's just switching nozzles, basically.
Switching nozzles, or if you have, something with two nozzles on it, you have red in one, green in the other, and you can specify, this one's going to print this ABS, this one's going to print this, and it'll print that for you.
Here's an interesting question. So you have two different nozzles with identical plastics, different colors. Can they mix the colors?
You could probably in a very small amount. Like you can't do like pixel by pixel kind of mixing. But you could have it print one layer in red, the next one in green, the next one in red, the next one in green. You could do things like that, but it would require a lot of setup work.
Okay.
I actually don't know.
You could do pixel,
You could literally do that.
It probably would not look good. Because you run into, so when you have like say black next to white printing next to each other, they're gonna melt into each other.
Well, that's what I was saying. I mean, like you have red, or you have yellow, and you have blue, and then you can have them print together and make
whatever is needed
something like that.
It would be, your nozzles are gonna be,
we haven't.
your nozzles are gonna be offset, so it's gonna be
Yeah,
really
that's true.
interesting in the G-codes, moving across, shutting off the one.
I don't think it's your laptop at all.
Moving over, turning on the one, going a little ways and turning on the
Meet
other.
M33P,
Getting
M33P.
that sync.
Trying to standardize all our patches on that.
While you guys are doing the setting up, I've seen some stuff online for, I don't want to call them, I guess, raw material creation machines.
Are you going
Recycle your own milk cartons or whatever else to make your own extrudable plastics. Has any of those worked out yet?
We don't have any at the space.
They sell them. There's
Philibot?
Philibot was the first one, and I think they're $350, and they'll extrude 3mm reliably. I heard people were having some issues with the 1.75mm. You get decent lengths for a while, and then you get some weird things like, so air bubbles are a problem still, I guess, and so it's more noticeable on the 1.75mm than 3mm.
Is this on secondary monitor right now?
I don't know.
But as it extrudes, do the air bubbles become an issue? As you create?
Yeah, yes and no. So with the 3mm extruder, you're putting a lot more plastic through. If they show up on the inside of the print, it's not noticeable. So at best, what you're doing is when you're telling it to generate the code, you're saying that you think the filament is about this diameter, and you're doing all the math based on that. But in reality, the filament's usually over or under in some portions. You won't have I've never seen a piece of 3mm filament that's actually 3mm. Usually it's like 2.7 or even as high as like 3.3 I've seen, like really bad stuff. So you average along the length, and so with that average, sometimes that makes up for the bubbles. You get a lot of air or broken pieces in filament, and your print, it'll keep printing, but your print quality is not going to be great. And if you're doing anything where you're actually stretching the filament, so there's a nozzle, it prints ideally at a size slightly under the nozzle size. So most of the 3D printers right now are coming with 0.4mm nozzles. So layer heights of like 0.35 are okay. But when you tell it to go really small, you're either feeding out less filament and moving slowly, or you're feeding out the normal amount of filament and basically stretching it by going fast to get the really small layers. So if you have an air bubble in there or a gap, your strand will basically snap and you'll have a weird part in the print. That's not a huge problem. So the one thing that I think a lot of people assume is that like you should be able to print something and get an awesome quality object, take it right out of the 3D printer and use it and print lots of them. They're really rapid prototyping. So you'll get an object really fast. You probably don't want to print 100 of that same object on a 3D printer. You'd want to cast it once you have a finalized design. But it's great for iterations. But you can do finishing to the part. So you can actually melt a lot of the materials. ABS is really volatile when mixed with acetone. And so you make this like goop, we call it slurry, and actually paint in and fill in all the gaps.
Similar to using slip with pottery.
Yeah, and so you can sand the outside. So we'll sand down because you'll get ridges. You'll be able to see that. You'll be able to see the lines on the side where the 3D printer goes. So we'll sand them down. We'll coat them with acetone, and we've even taken we saw it on a Hackaday a little while ago. You take a glass jar, you put your object in the glass jar, stick it on the heated platform in the printer, and put just a drop of acetone in and cover the jar. And the acetone heats up, and it basically just melts the sides of the objects really quickly. Like 5 minutes is too long. You'll have a nice round wavy object after 5 minutes. It's really quite fast. So you do all these things to finish your object and get a nice finished piece, and then you cast from there if you really want to do casting and pouring or something. So is it a huge issue? Yes, if your goal is to get a perfect print out of the 3D printer, but my guess is you'll get frustrated with that very fast. It's not something that's easy to accomplish. And like the prints that Michael passed around, those are really, really nice prints. But that printer was played with for hours to get them to that point.
Hours, yeah, if not days, weeks.
So, is this not working?
I don't think so. Did you want to try handing me that laptop and we'll open SCAD on there?
Yeah.
Yeah.
It's got
power.
Oh man, that was exciting.
Not nearly as exciting to you as it was to me.
Yeah, I know. Get this guy. Is that orange cable plugged into anything right behind you, sir?
No. You want it?
If not, yeah, well, Patrick's got the other end, I think. I don't know, Patrick, if you want to... Yeah, if you want to risk discovering what's behind the lamps.
What's behind that? Paying no attention.
Oh, gosh. You're amazing, sir. Thank you. Whoops, sorry.
That's
it
all right.
finally happened.
I'm used to it.
I don't know if that's...
This is not the right end.
Actually, it's a TF20. TF201, it's one of the original transfer with the full aluminum case.
Oh, Tron. There we go, Tron.
I just rebooted mine.
Oh, I know.
Yeah, this is not. It's part plastic.
No, it's actually working.
I've also made the assumption that OpenSCAD is on here.
Oh, actually, this part
So,
lines aluminum all the way up and around.
Wow.
It's
Gotta
because
make it heavy at the ends of the wires just a little bit.
the reason why
Yeah.
this is plastic is because the
So we can pull up
Wi-Fi
Notepad
antennas
and demonstrate with the shadow.
The whole metal
OpenSCAD just render
kind
on
of
here.
blocked part
here
of
we
the
are.
signal, so they took care of that with an external antenna.
Oh, yeah.
But yours already has that,
Awesome.
that modification.
No OpenGL support.
Oh, that's fine.
I use mine all the time. I was surprised how much I use it. Kindle,
It might be closing that background in the background.
Okay.
Presentations. When I'm in a presentation and they're letting me take
Make sure it doesn't
photos of the
explode.
Okay.
presentation, I'll take a
So
photo of it
this program that we're showing you
in Android to
is
just
called
see
OpenSCAD.
convert those images.
So the nice part about this is if you want to lay out something specifically, if you want to go and specify sizes of everything or make something parametric, so you notice there's a website called Thingiverse right now, which is kind of like a 3-mile repository for 3pers. And they have a new feature that showed up like 2 months ago where they have all these parametric designs where you can say, I want something this size, or it should have this many snowflakes in, or I want my iPhone case to have this many circles cut out at the back. That's all done. They're feeding it into an OpenSCAD script and then creating the object. So this program is not designed to manipulate graphically at all. So this object here, I can rotate it, I can move it around, I can look at how it shows up, but I can't go and do anything without modifying the code over here. You're not constrained to using this editor, but for simplicity's sake, we'll use it for now. So we'll start really basic. So you render everything in here by telling it shapes and sizes. So if I just give it one size here, everything's done in millimeters. So this will be a 10 millimeter cube. So that is a 10 millimeter cube. If I go up here under design and I say export as STL, I'll get the file to use for my 3per. That's a 10 millimeter and cube, and it's solid. I don't have to worry about holes or anything in the center. And when you go to actually slice it, that's when it goes and converts the inside and says, oh, we're not going to fill this all the way because it's pointless. So the inside of this can really be mostly hollow and it prints odd-shaped infill. You can add brackets in and then specify X, Y, and Z dimensions. So this is no longer really a cube, I realize. But shaped like that. All the primitives are supported. So cube, cylinder, sphere.
Keyboard.
Don't you need 2 dimensions for a cylinder?
Interestingly enough, no. You will have to give them though if you want to specify something. So it interprets the first as, so if I just give it 10, it uses a default radius of 1, and it's just using that as the height. So you can specify them, and we can say things like radius equal to 5. So now we have a cylinder. You'll notice that it doesn't look like a cylinder. It's got all these weird sides on it that are square. It renders this because it's easier to do, so it's not as computationally intensive. And your resolution on your printer, you'll probably never notice for something this small. You can change the resolution. You can tell it, oh, I want it to be like perfect on every side. So we use this, it's a variable that you can set in any command. It just tells it basically how many objects that are all around on a sphere or a cylinder. So there's 40 around on this one now. So it's going to be much finer. Again, at the default setting, I want to say it's 20 as the default. You probably won't notice it unless you're printing a really big object, and then you'll see the sides. But the moment you start adding more vertices to the outside, it will take longer to generate the G-code. It will take longer to print because it's doing very fine motions around the outside then. So we can do things like that. And the nice thing about the cylinder is you can specify the radius of each end. So we'll say R1 and R2, 0. Now we have cone. So that's wonderful. We can do one shape. That's not terribly exciting. Who wants to print cones, spheres, and boxes all day? So we want to add stuff in and combine it to do things. Arbitrary shapes. See, it's inside of there. And if I want to see, well, where exactly is my cylinder, or what exactly am I covering? It's just a neat little pound sign. It works kind of like a comment if you're familiar with software design. And so it'll actually highlight the object that you have the pound sign in front of. So you can see the cones there. They look like they're joined. OpenSCAD treats them as two separate objects at this point if you really want to make sure they're joined. So if you export this to print, it will treat it as one solid object. But if you want OpenSCAD to do things like rotate it or move it as a unit, you have to use this union command around it. This program is again free. It's updated fairly regularly. They keep adding new functions to it. It is not limited to the simple stuff I'm showing you right here. We've actually gone and designed an entire parametric 3D printer for our space. We did all the design in the software. And the nice part is the file formats that export from here, we can take a